Hi students, welcome to our channel. This is our 7th video on trigonometry. In this video we are going to solve 5 problems, out of which first 2 problems are similar to the 5th problem of the previous video. Let me move on to the first problem. Prove that tan theta divided by 1 minus cot theta plus cot theta divided by 1 minus tan theta is equal to 1 plus secant theta into cosecant theta. So in the right hand side, trigonometric terms are secant theta and cosecant theta. We know how to get secant theta and cosecant theta. Suppose if we are succeeded to get 1 by cos theta and 1 by sin theta, so then ultimately we will get secant theta and cosecant theta. So therefore we have, but in the left hand side the terms are tan theta and cot theta, but we know how to express tan and cot in terms of sin and cos. So therefore start the first step by expressing tan and cot in terms of sin and cos. Let me start the first step. LHS is equal to, so tan theta is equal to sin theta divided by cos theta divided by 1 minus cot theta is cos theta divided by sin theta plus cot theta is equal to cos theta divided by sin theta or divided by 1 minus sin theta divided by cos theta. Now simplify the denominator part, 1 minus cos theta by sin theta. So here you have to find the LCM for 1 and sin theta. LCM is sin theta. So then you have to multiply 1 by sin theta. So therefore numerator becomes sin theta minus sin theta is there. Therefore cos theta as it is. Then numerator sin theta by cos theta as it is plus. So cos theta divided by sin theta as it is or divided by, here denominator LCM is cos theta, so then 1 becomes cos theta minus sin theta. The next step, so we know how to divide the fraction. So when you express divide sign into multiplication sign, then this becomes reciprocal. Therefore this sign goes to numerator. So then sin into sin square theta divided by this cos theta comes to denominator, then it becomes cos theta into sin theta minus cos theta plus. Similar here, this cos theta goes to numerator, becomes cos square theta, then this sin theta comes to numerator, then sin theta into cos theta minus sin theta. Here observe the denominator part, cos theta into sin theta minus cos theta. Here sin theta into cos theta minus sin theta. Term within the bracket is sin theta minus cos theta minus sin theta. But here sin is positive, cos is negative. But here sin is negative, cos is positive. So next step, very important. So we have to get the term within the bracket is same with the same sign. So here sin theta minus cos theta, then we have to get sin theta minus cos theta only, then we cos should convert it into negative sign, and sin we should convert it into positive sign. So therefore very important step this is. So we have discussed in the 5th problem of the previous video. So first fraction I will keep as it is, sin square theta divided by cos theta into sin theta minus cos theta minus cos square theta divided by sin theta into sin theta minus cos theta. So plus becomes minus, then cos theta minus sin theta becomes sin theta minus cos theta. Now term within the bracket are same and with the same sign. So next continue. Now we have to subtract these two. So denominators are not equal, therefore we have to go for LCM. So LCM is sin theta into cos theta into sin theta minus cos theta. Then Here cos theta into sin theta minus cos theta is there. So which is not there? Sin theta. Then we have to multiply the numerator by sin theta. So sin square theta into sin. So sin cube theta minus sin theta into sin theta minus cos theta is there. Then we have to multiply by cos theta to the numerator. So cos square theta into cos theta, cos cube theta. So now it is of the form a cube minus b cube. So what is a cube minus b cube? A cube minus b cube is equal to a minus b into a square plus b square plus ab. So a is sin theta, b is cos theta. So according to that becomes sin theta minus cos theta into sin square theta plus cos square theta plus sin theta into cos theta whole divided by denominator sin theta into cos theta into sin theta minus cos theta. So sin theta minus cos theta, sin theta minus cos theta get cancelled. Then remaining terms sin square theta plus cos square theta plus sin theta into cos theta whole divided by sin theta into cos theta. But we know that what is sin square theta plus cos square theta? What is sin square theta plus cos square theta? It is 1. So therefore 1 plus sin theta into cos theta whole divided by sin theta into cos theta. Now we have to divide both 1 and sin theta into cos theta by sin theta into cos theta. So 1 divided by sin theta into cos theta plus sin theta into cos theta whole divided by sin theta into cos theta. So what is 1 by sin theta? That is cosecant theta into 1 by cos theta, that is secant theta plus so same terms 1 by 1 is 1. So therefore 1 plus secant theta into cosecant theta. So this is our required RHS. So very important step is converting plus sign into minus sign. Then it becomes cos theta minus sin theta becomes sin theta minus cos theta. Okay, please pause the video and note it down. Now I'll move on to the next step, second problem. Second problem is tan theta divided by 1 minus cot theta plus cot theta divided by 1 minus tan theta is equal to tan theta plus 1 plus cot theta. This is our second sum. In the right hand side, tan theta and cot theta. In the left hand side also, tan theta and cot theta. Dear students, to get tan theta and cot theta, express either tan or cot into its reciprocal form, either tan or cot. It is your convenient. In the left hand side, I will express cot theta as 1 by tan theta. Here also cot theta as 1 by tan theta. Okay. So LHS is equal to tan theta, I will keep as it is, divided by 1 minus cot theta is reciprocal of tan plus cot theta 1 by tan theta whole divided by 1 minus tan theta. Either convert tan theta or cot theta. But equal to. Now simplify this. So tan theta, the numerator part as it is. So then here 1 can be write as 1 by 1. So LCM is tan theta. So then it becomes tan theta minus 1 plus, so 1 divided by, this tan is in the denominator, this is also in the denominator, therefore the denominator part is tan theta into 1 minus tan theta Next, we have to divide this, correct? So this tan theta goes to numerator. So tan into tan theta, so that is tan square theta whole divided by tan theta minus 1 plus 1 divided by tan theta into 1 minus tan theta. Next step is very important. Here tan minus 1, here 1 minus tan. Tan is positive, 1 is negative, but here 1 is positive, tan is negative. So then we have to convert it as tan theta minus 1. So then plus becomes minus in the next step. Very important step. Tan square theta divided by tan theta minus 1 minus 1 divided by tan theta into tan theta minus 1. Now we have to subtract these two fractions. So denominators are not equal, therefore we have to go for LCM. LCM is tan theta into tan theta minus 1. Next step. Tan theta into tan theta minus 1. So tan theta minus 1 is there, so it is not tan theta. So then we have to multiply this term by tan theta, not only for denominator, also for numerator. Tan square theta into tan theta, that is tan cube theta minus. So tan theta into tan theta minus 1, the same term is there. So then we have to multiply by 1. 1 into 1 is 1. But the first term is in the cubic form, but 1 is not in the cubic, but we can write it as 1 cube, correct? So now it is of the form a cube minus b cube. So what is a cube minus b cube? Just we have seen in the earlier problem, that is a minus b into a square plus b square plus ab. A is tan, so therefore a minus b, tan theta minus 1 into a square. A square is tan square theta plus b square, that is 1, plus ab, tan theta into 1, so that is tan theta whole divided by, so tan theta into tan theta minus 1. So tan theta minus 1, tan theta minus 1 get cancelled. So then remaining terms are tan square theta plus 1 plus tan theta whole divided by tan. In the numerator we are having 3 terms, the denominator only 1 term. So each term of the numerator must be divided by tan theta now. So therefore I have divided separately. Tan square theta divided by tan theta plus tan theta divided by tan theta plus 1 divided by tan theta. So here 2 times, here 1 times. If I divide it 1 time, then what is left out? Tan theta is left out. 1 time tan theta plus tan theta by tan theta. So 1 by 1, that is 1 divided by 1 by tan theta. What is the reciprocal of tan theta? That is cot theta. So this is our required RHS. Tan theta plus 1 plus cot theta. Now I will move on to third problem. Prove that prove that 1 plus tan square theta plus of 1 plus 1 by tan square theta is equal to 1 by sine square theta minus sine to the power 4. In the right hand side the trigonometric ratio is sine, but in the left hand side it is tan. So we know how to get the sine from tan. So let me start with the left hand side. 1 plus tan square theta plus 1 plus 1 by tan square theta. The term in the first bracket is 1 plus tan square theta, but we know that what is 1 plus tan square theta? It is secant square theta, correct? Secant square theta plus 1 plus What is 1 by tan? 1 by tan is cot. So 1 by tan square is cot square theta. Next, secant square theta plus, what is 1 plus cot square theta? It is third identity. 1 plus cot square theta is equal to cosecant square theta. What we require in terms of sine. Secant square theta. Secant theta is the reciprocal of cos theta and cosecant theta is the reciprocal of sine theta. So therefore in the next step express both the term in its reciprocal form, that is 1 by cos square theta plus 1 by sine square theta. Now we have to add these two fractions. So denominators are not equal, therefore we have to go for LCM. LCM is sine square theta into cos square theta or cos square theta into sine square theta. So cos square theta is there, then we have to multiply by sine square theta. So 1 into sine square theta is sine square theta plus sine square theta is there, then we have to multiply by cos square theta. 1 into cos square theta is cos square theta. So what is sine square theta plus cos square theta? It is 1, that is the from first identity, divided by cos square theta into sine square theta, that equal to 1 divided by, so sine square theta that we got now. Now we have to express cos square theta in terms of sine square theta. What is cos square theta? That is 1 minus sine square theta from the first identity. Sine square theta plus cos square theta is equal to 1, therefore cos square theta is equal to 1 minus sine square theta into sine square theta. So 1 divided by sine square theta into 1, that is sine square theta minus sine square theta into sine square theta, sine to the power 4 theta. This is our required RHS. So this is one of the special problem because it involves all three identities. 1 plus tan square theta is equal to secant square theta, that is the second identity. 1 plus cos square theta is equal to cosecant square theta, that is the third identity. Sin square theta plus cos square theta is equal to 1, that is the first identity. So it involves all three identities, therefore from the point of examination this problem is very important. Please pause the video and note it down. Now I'll move on to the fourth problem. Fourth problem is prove that secant square A into cosecant square A is equal to tan A plus cot A whole square. So in the right hand side terms are in tan and cot, but in the left hand side secant and cosecant. Secant have the relation with the tan, cosecant theta have the relation with the cot, correct? So in the left hand side start with the expressing secant square theta in terms of tan and cosecant square in terms of cot. So LHS is equal to secant square theta. What is secant square theta? 1 plus tan square theta is equal to secant square theta. Yes, this is the second identity. Similarly, 1 plus cot square theta is equal to what? Cosecant square theta. This is the third identity. Now we are having these two terms. So therefore secant square theta can be written as 1 plus tan square theta. So secant square A, therefore 1 plus tan square A into cosecant square theta. Cosecant square theta is 1 plus cos square theta. So 1 plus cos square A. Now we are expressed the product of monomial as product of binomials. We know how to multiply the binomials, correct? So now start to multiply the binomials. 1 into 1 plus 1 into tan square A plus into plus cos square theta into 1, so cos square theta cos square A plus into plus cos square A into tan square A, that is tan square A into cos square A. In the next step, keep the first three terms as it is, 1 plus tan square A plus cot square A plus tan square A. Cot square theta is reciprocal of tan, therefore I will express tan cot square A as 1 by tan square A. So tan square A, this tan square A get cancelled, then we got plus 1. Here already one more is 1. So 1 plus 1 is 2. So therefore I will write first these two terms, tan square A plus cot square A plus 1 plus 1 is 2. But we required tan A plus cot A whole square, that is A plus B whole square. A square plus B square plus 2AB. What is A? Tan. What is B? Cot. So therefore we have to write 2 as 2 into tan theta into cot theta. So tan square A plus cot square A plus 2 tan A into 1 by tan A. 1 by tan A. Suppose tan A get cancelled there. What is remainder? 2 into 1 is 2. So same. Correct. Next step. Tan square A plus cot square A plus 2 tan A into what is 1 by tan? It is cot A. Now maybe we have got A square plus B square plus 2 into A into B. So what is A square plus B square plus 2AB? That is A plus B whole square. Here tan and cot, tan square A plus cot square A plus 2 tan A into cot A. Therefore we can write it as tan A plus cot A whole square. This is our required RHS. Now we will move on to the fifth problem. Prove that sin A plus cosecant A whole square plus cos A plus secant A whole square is equal to tan square A plus cot square A plus 7. The right hand side terms are tan and cot, the left hand side sin, cosecant, cos and secant. So if you take the first bracket, secant A plus cosecant A, it is whole square, you know it is of the form A plus B whole square. Second term also in the form of A plus B whole square. Now in the first step, expand sin A plus cos A whole square and cos A plus secant A whole square using A plus B whole square. LHS is equal to sin A plus cosecant A whole square, sin square A plus cosecant square A square plus B square plus 2AB, 2 into sin A into cosecant A plus A square plus A plus B whole square. Once again, A is cos, so cos square A plus secant square A plus 2 cos A into secant A, that is equal to sin square A plus, I will take the cos square A now, rearranging the terms, plus cosecant square A plus, then I will take secant square A plus remaining two terms, 2 sin A into cosecant A plus 2 cos A into secant A. But we know that Sin square a plus cos square a is equal to what? It is 1 plus cosecant square a, it is equal to 1 plus cot square a plus what is secant square a? Second identity, 1 plus tan square a is equal to 1 secant square a. So therefore secant square a can be written as 1 plus tan square a. So you require tan and cot. So tan and cot we got plus 2 sin a into sin and cosecant are reciprocal to each other. Therefore I will express cosecant a as a reciprocal of sin. So 1 by sin a plus 2 cos a into secant a is the reciprocal of cos, 1 by cos a. Now this sin a get cancelled, this cos a get cancelled, 2 into 1 is 2 plus 2 into 1 is 2. So then 1 plus 1 plus this one plus 2 plus 2 plus remaining terms tan square a plus cot square a. Add this 4 plus 5 plus 1 6 plus 1 7 7 plus cot square a, sorry tan square a plus cot square a. This is our required RHS. This is also important problem because it involves all three identities. Sin square a plus cos square is equal to 1, 1 plus cot square is equal to cosecant square theta, 1 plus tan square theta is equal to secant square theta. So hope you understood this problem, sir. Suppose if you have any doubts, so please give your comments. Thank you.